All right, let's talk about one of my favorite tools in all of trigonometry, the sum and difference identities. Seriously, these things are like a secret key. They let you find the exact values for angles you'd normally think are impossible to solve without a calculator. So let's dive right in.
Okay, let me throw a puzzle at you. You know the exact value for cosine of 45 degrees, right? And cosine of 30 degrees? Yeah, those are the easy ones from the unit circle. But what about cosine of 75 degrees? That's not one of our usual suspects. So how on earth are you supposed to find its exact value without just grabbing a calculator?
So your first thought might be, hey, can't I just add the cosine of 45 and the cosine of 30? It seems logical, right? But nope, it doesn't work that way. Go ahead, try it on a calculator. If you don't believe me, the numbers won't match up. Trig just isn't that simple. We need a smarter way to do this.
And that smarter way? Well, it's basically a trigonometric cheat code. We're talking about the sum and difference formulas. These are the secret weapon that lets us take an awkward angle like 75 degrees and crack it open by using pieces we already know and love.
So what are these things, really? Well, simply put, they're just formulas that let us find the trig value for an angle that's a sum or difference of other angles. You know, like our friendly 30, 45, and 60-degree angles. They're basically the bridge that takes us from an angle we don't know to angles we do.
Okay, let's look at the formulas themselves. For sine, the pattern is pretty straightforward. It goes sine, cosine, cosine, sine. And check this out, the sign in the middle is a perfect match. If you have sine of a plus b, you use a plus in the formula. Simple. But now, look at cosine. This is where you gotta pay attention. The pattern is cosine, cosine, sine, sine. But the sign, it flips. If you're doing cosine of a plus b, you use a minus in the formula, and vice versa. Seriously, this is the #1 thing people forget, so burn this into your brain.
Okay, theory's great, but let's see these things in action. It's time to go back and solve that problem from the beginning, finding the exact value for the cosine of 75 degrees.
We're going to tackle this with a simple 4-step game plan. First, break the angle down. Second, pick the right formula for the job. Third, plug in all the values you already know. And fourth, just do the math and simplify. Let's do it.
All right, step 1, break it down. We need to look at 75 degrees and think, how can I make this using my favorite angles? Well, the easiest way for sure is just 45 degrees plus 30 degrees. Perfect.
Okay, so now for step 2, choose the formula. Since we're doing the cosine of a sum, we need the cosine sum identity. That's the one that goes cos A, cos B, minus sine A, sine B. In our problem, A is our 45 degrees and B is our 30 degrees.
And now for step 3, the fun part. We just plug everything in. We know all of these values, right? So cos of 45 is the square root of 2 over 2, cos of 30 is the square root of 3 over 2, then comes the minus sign. Sine of 45 is also the square root of 2 over 2, and sine of 30, that's just 1/2. Now all we have to do is clean this up.
And hey, just to hammer this point home one more time, look, we started with cosine of A plus B, right? 45 plus 30. And the formula we're using has a minus in it. See? The signs flip for cosine. It's so important to remember that.
But wait, there's more. These formulas aren't just for expanding things. Their real superpower is often working backwards, taking something that looks really messy and complicated and collapsing it into something super simple. Let me show you what I mean. So, imagine you see this thing on a test. I mean, look at it. Cosine of 80 degrees, cosine of 20 degrees. We don't know those values off the top of our heads. It looks like you're totally stuck without a calculator. Or are you?
The trick here isn't about calculating the pieces. It's about recognizing a pattern. Just look at the structure. You've got cos, then a plus sign, then sin. Does that look familiar? It should.
Because that whole big, messy thing, it's just the cosine difference formula. Remember? The one that goes cos A, cos B, plus sine A, sine B, is just the simpler version, cos A minus B, in disguise.
So we can just collapse that whole expression down. Our A is 80 degrees, our B is 20 degrees, so the whole thing simplifies to just cosine of 80 minus 20, which is, of course, just cosine of 60 degrees.
And cosine of 60 degrees? We all know that one. It's just 1/2. Bam! See what we did? We took this monster of an expression that looked impossible, and, just by recognizing the pattern, we turned it into one of the simplest values on the unit circle. That's how powerful these identities are.
Okay, so before we wrap up, let's just quickly go over the key takeaways here. What are the most important things to remember?
First off, you can use these identities to find exact values for weird angles by just breaking them down into the good old 30s, 45s, and 60s. Second, and I'm going to say it again, watch those signs, especially for cosine, where the sign in the formula is the opposite of what you'd expect. And finally, don't just think forward. Learning to spot these patterns backwards is a total game changer for simplifying crazy-looking problems.
So there you have it. You now have the keys to the kingdom. You can unlock a whole bunch of new angles. So here's a little challenge for you. What other angles can you figure out now? How about the sine of 15 degrees? Or maybe the cosine of 105? You've got the tools now. Go give it a shot.